Hello. In this lesson, we'll learn about construction quality management. We'll be able to define quality and quality management and identify the processes of quality management. And two of these processes, quality control and quality assurance, will be able to distinguish between them. Construction quality management is a bunch of tasks to ensure that the construction is performed up to the plans and specs, the quality requirements that you have. This is just an extension of the definition here that while you do that, you do it while you're not impacting much the time and the budget and also the safety of the project, because these are the other kind of bigger overarching goals for any construction project. There are possible definitions of quality. So we've seen the quality management aspect. Now let's focus on quality here for a while. So there are different definitions of quality depending on where you look at it. Some people here, like the ISO, it's one of the main kind of quality certification processes. It's international certification, kind of certifying the quality of your business or your operations. And here it's the degree to which that you fulfill some requirements. So you have requirements set and you're trying to fulfill these. Based on the Project Management Institute, it's the idea that the project deliverables meet requirements. So again, requirements here come into the picture. Philip Crosby is also one of the early leaders in quality management. He defined it as conformance to requirements. So again, it's kind of adherence, meeting, conformance to requirements. And then Joseph Joran, also one of the leaders in quality management field, defined it as the fitness for use. Which you can say it's defined by some requirements that represent what use you want out of this product or project. So we can see here it's conformance, it's meeting of some kind of requirements. For construction, quality projects should adhere to a bunch of requirements, or we can say three main requirements here. First one is the local building code. So building in California will be different than building in, let's say, Texas. The weather is different. The political system even is different. The structure of how cities and counties run is different. So you will have different local building code. They're built on the same uniform kind of building code and international building code, but there are some unique requirements for each jurisdiction. And also the other group of requirements is the standards, so structural design standards or mechanical or electrical. So these are published by the different professional groups. And then there is the other third group here is the performance goals and requirements that depend on the owner of every unique project. So every owner is different. They have different organizations. They have different employees. They have different culture. So that's represented in different requirements. So you're basically here, your building should satisfy local code, the standards of design, and the last thing here is the performance requirements as defined by the owner. Now, quality management goes through three different steps that it's kind of going in a loop. So quality management starts before you do the actual work, which what we call quality planning. So you identify the quality requirements. Again, requirements here is a really big deal. And the processes to manage the quality. So the processes to establish these qualities, revise them, to manage them, who will be in this quality management team, what templates or standards you will follow. So that's quality planning. Next is quality assurance while you do the work. Which is kind of the audit process that you have in place to make sure that you're fulfilling these requirements. You're not testing that much. That's left to quality control. So after you do the work, sometimes while you do the work, you take samples, you do tests, but you do the tests after you build for things, for example, most of the time. So you take a core of a concrete structure that you built, or you take soil samples from an embankment or a compaction you did. So you're monitoring specific metrics here that relates to the requirements, and then you're trying to make these measurements, and then based on these measurements, you adjust any work plan or settings that you have to go back on track in terms of achieving the requirements. So here you have to set quality requirements and processes. Then you need to take samples here after the work, but between you have to audit the process. You have to make sure that everything is followed and your threshold is satisfied. So kind of this is the work or the cycle here. So now quality planning tells you to do the right things. So an owner will come with different set of requirements. A jurisdiction will come with different local code. So you do the right things. Quality assurance will tell you to do the things right. So these things that you identify, these requirements, you will manage them in the right way through quality assurance. And then quality control will tell you, I'm done with the right things right, in the right way. So let's see an example here. The concrete work. Quality planning will identify quality requirements in terms of strength, permeability, or consolidation. And also will tell you who will manage the quality. So is it the engineer, supplier, or the contractor? Quality assurance will set acceptance criteria and audit the satisfaction of these criteria of different concrete tests. So strength, it's compressive strength that you measure based on a specific standard, permeability, water cement ratio, and then consolidation is a slump test. So after setting all of that and then using this to audit the quality control, which is how frequent you should make these tests. So the frequency of the different tests that you identified or outlined in the quality assurance, and based on this frequency, it will show you how engaging are you. Is it every week, or per every pour of a concrete, every floor? So it will see how much corrective actions or how frequent corrective actions you can make. Now, quality planning is kind of happens in the beginning. You revise it over the course of the project, but the main two functions of quality management is quality assurance and quality control. And these two main functions are usually confused. They are mixed. So people will always say QA, QC, QC, QA, and they assume they refer to the same thing. And that can lead actually to construction defect claims. So defects happen, and then people start pointing fingers because they don't know what processes or procedures that should follow. Is it QA, QC, and responsibility is not clear. But in simple words, QA is the responsibility of the owner. QC is the responsibility of the contractor. That's kind of what expectation in the industry we have now. So quality assurance will tell you right things the right way, while quality control will tell you what we have done are what we expected. So you have a threshold to achieve and you're measuring against that. Quality assurance will tell you this threshold, detailing the requirements that you have in the quality plan. Another thing is quality assurance is based on observations and audits. So your goal is not to do the tests. Maybe you do tests to validate the quality control tests, but your tests are not the main tool here. Quality control inspection tests is the main tool. You're doing a lot of tests, you document the results, you compare it to the threshold, and make corrective actions. This is why quality control is more like about detecting defects, and this is why it's corrective. So when you find a defect, you correct it. In quality assurance, it's about preventing defects. So having processes and the culture to people caring about quality, so it's preventive. In quality assurance, the focus is on the life cycle performance because these requirements came by the owner. So they identify the requirements by the owner, and the owner cares more about life cycle. But quality control is about the performance of the work right now, because you cannot measure something that will happen in 5 years because the contract is only for 1 year. You only constructing the project here. So the focus here is a little different, and this is why the quality assurance is the importance or the skin in the game here. Who has a skin in the game in terms of life cycle performance is the owner, right? Or they can delegate the architect or engineer. But here, quality control, it's the GC. So quality control, quality assurance requirements are outlined in the drawings and specifications. So this is where you will find the requirements for the work. The teams that are responsible for QA, QC, for contractor, it can be the existing staff, so superintendent or field engineer. Typically, this is what project engineer, field engineer, the main difference here is that field engineer is more about quality field work, but then project engineer is about management aspects of the project. If you're having a lot of mechanical components or piping, so in industrial projects, there's a lot of tests about welding and pressure and all of that. It's a lot of work that be handled by only a field engineer. You need someone dedicated, trained for that. So there is a career called quality engineering. You can be a quality engineer and be hired in such industrial projects. On the owner side, it can be done by the owner representative or an inspector. So some owner agencies, especially public agencies, they have inspectors or quality control specialists. Or you can just, if the owner is just a simple organization, they will assign it to the architect in this case, as done in the design bid build AIA contract forms. One last thing here I want to highlight is the cost of quality. So people always say do more tests will be more confident, but you have to be careful here because more tests means more costs, of course. Do we need more tests? Like, do we need 1, 2, or 50 tests to test or to affirm that the compaction here is up to requirements? So this study here measured the quality performance, meaning that they kind of focus on one project and they collect a lot of samples in terms of how many tests they collected, and they measure also the amount of rework that need to be done when defects are found. So when quality management expenditure here relates to how many tests, that's kind of the representation of the amount of effort you put into testing and quality. So the less expenditure on quality management you have, of course the lower quality management processes cost you have, but the higher possibility of rework you will also have. So kind of this is on the lower quality effort side. But the more effort you put in quality, the cost of your quality management team and processes will go high, and it's linear. But then the rework, if you see here, goes down. The possibility of rework goes tremendously down when you put little effort in the beginning. But then more effort you put in, it doesn't pay off that much. So this means that at some point you have to invest into quality, but after that it's just a wasted effort. So this is kind of the total cost of quality, of the cost of managing the quality or funding the quality management program you have, and the cost of doing rework because you didn't pay attention or didn't do much tests or didn't pay attention to quality that much. So there is kind of an inflection point here, a minimum point somewhere here. So just conceptually understand that quality is important, but there is a point where you invest initially a lot of effort in that, but after that there's no payoff that much. Thanks for watching. I will see you in other videos. Take care.